Hi everyone. Today we're going to learn about the factors that affecting the enzyme activity. So we are still in chapter 1 enzymes. In previous lesson you learned about the characteristics of the enzyme, enzymes in lowering of activation energy, mode of action and enzyme specificity. So before we start to learn about the factors affecting the enzyme activity, let me do a small recap about the previous lesson. So in previous lesson, you learned about the enzymes, right? So enzymes are globular protein. Enzymes also as a catalyst speed up the biochemical reaction. And also you learn how the enzyme lowering the activation energy. So when there is an enzyme, the reactant just use the minimum amount of the activation energy to reach the transition state before release the product. If let's say there is no enzyme, so what will happen? The reactants need more energy to reach the transition state. So these are the basic difference between the presence and absence of the enzyme in any biochemical reaction. Next, you also learn about the mode of action. There are two types of the models, such as lock and key hypothesis and induced fit theory. So the basic difference between these two models is in terms of the flexibility of the active site. Based on the lock and key hypothesis, the active site has a fixed and rigid geometrical conformation and not flexible. So it means the shape of the substrate must be complementary with the shape of the active site. Then only can bind at the active site. However, for the induced fit theory, the active site is more flexible. So it means the substrate binding will stimulate the enzyme to change its shape together with the shape of the active site so that the substrate can bind at the active site. That's why the induced fit theory is accepted. Then you also learn about the enzyme specificity. So these are the important topics you learned in previous lesson. Okay, let's be focused on today's lesson. Today's lesson, you're going to learn about the factors such as the enzyme and substrate concentration, temperature, pH, and cofactor. So overall, there are 6 factors that affect the enzyme catalytic rate of reaction. So at the end of this lesson, you should be able to describe the factors that influence the activity of enzymes. So these are the factors. Okay, first we look at the pH. All the enzymes have their narrow range of the pH. It means optimal pH. So this is the optimum pH for the pepsin and this is the optimum pH for the trypsin. So it means the enzyme work best and effectively at their optimal pH. If the pH lower or higher than the optimal pH, the enzyme will be denatured. It means the chemical bonds that hold the 3D shape of the enzyme will be disrupted, which can cause the denaturation of the enzyme. And also, the shape of the active site also affected. So, the substrate cannot bind at the active site. Since the 3D shape of the enzyme affected and there is no active site, so the substrate cannot bind at the active site. pH influences the charges hydrogen ionic bonding within the enzyme. So that's why at the optimal pH, the enzyme work effectively. The next factor is temperature. All the enzymes also have the optimal temperature. So as the temperature increases, the rate of the reaction increase until the optimal temperature. So above the optimal temperature, the enzyme activity will reduce. Until certain temperature, the enzyme activity will stop. completely. So as the temperature increases, the kinetic energy of the substrate and then the enzyme will increase. And the substrate also will collide more often and will bind at the active site of the enzyme. Thus, the rate of the reaction increase until the maximum rate of the optimum temperature. If let's say above the optimum temperature, what will happen? The chemical bonds of the enzyme affected so that the enzyme denatured. Then the enzyme lost their 3D shape and also lost its catalytic properties. Therefore, the substrate cannot bind at the active site. The third factor is enzyme. So as the enzyme concentration increases, the rate of reaction increases. And then we also assume that the temperature and pH are kept constant. So the rate of reaction directly proportional to the enzyme concentration. Okay, the next factor is substrate. So based on the graph, initially as the substrate concentration increases, the rate of reaction increase until a certain point that known as saturated point. It means the enzymes saturated with the substrate. It means the substrate bind at all the active sites of the enzyme so that excess of the substrate cannot bind. There is no free active site. That's why above the saturated point, the rate of reaction constant. So this is the example of the substrate concentration graph. As I explained earlier, initially as the substrate concentration increases, the rate of reaction increases until the saturated point. And above the saturated point, the rate of reaction is constant. So you can understand from the picture A, B, and C. Okay, initially, there are many enzymes. However, two substrate only. So the two substrate bind at the active site of the enzyme. So the rate of reaction increase. And then when there is a high substrate concentration, so all the enzymes occupied with the substrate. Still the rate of reaction increase until the saturated point only. So above the saturated point, the rate of reaction constant because based on the picture C, there are excess of the substrates, but there is no free active sites. So even though there is a lot of substrate, the rate of reaction still constant. So this is the state of the enzyme during denaturation process. As I explained earlier, based on the factor pH and also the temperature, when you see from the graph, above the optimal pH and also above the optimal temperature, the enzyme activity decreases because of the denaturation of the enzyme. So when the enzyme denatured, what will happen? The chemical bonds that hold the 3D shape of the enzyme disrupted. So you can see from the picture here. So initially the enzyme's native state is 3D shape and also the enzyme has a active site. When the enzyme denatured, what will happen? The enzyme, the chemical bond that hold the 3D shape of the enzyme disrupted and then the shape of the enzyme changed and also there is no active site. So when there is no active site, it will prevent the substrate binding. That's why the enzyme substrate complex cannot form and then the rate of reaction decreases. The next factor is enzyme cofactor. Enzyme cofactor is a non-protein component which bound tightly or loosely to the enzyme. Enzyme cofactor is actually make the enzyme catalytic reaction more effectively. So there are three categories of the enzyme cofactors such as inorganic ions, prosthetic group, and coenzymes. However, the prosthetic group and coenzymes are organic compounds. Okay, let's we look at the inorganic ions. The inorganic ions attached to the enzyme temporarily. Examples of the inorganic ions are zinc ions, calcium ions, magnesium ions, ferrum ions, sodium ions, and chloride ions. Okay, the zinc ion is the cofactor for the carbonic anhydrase. Chloride ions are the cofactor for the salivary amylase. So this is the example of the inorganic ions. And then the prosthetic group, for example, the heme as a prosthetic group. Prosthetic group also non-protein organic, which binds tightly and permanently to the enzyme. However, the coenzyme bind loosely and temporarily to the enzyme. So for example, the heme, the enzyme catalyze the hydrogen peroxide into oxygen and water. So enzyme catalase have the heme group as a prosthetic group. And then the cytochrome oxidase has the prosthetic group such as heme. Another example is FAD. Next, the coenzyme. Coenzyme, for example, the NAD+. Mostly the coenzymes can be obtained from the vitamins. For example, the NAD+ can be obtained from the vitamin B. The coenzymes also, as a transfer agent, transfer the electrons from one enzyme to another enzyme. As a summary, in this video, you learn about the factors that affect the enzyme activity. So total of 6 factors, but in this video, you learn about the 5 factors such as the pH, temperature, enzyme concentration, substrate concentration, and cofactor. Another one more factor is inhibitor. So in next lesson, you will learn about the inhibitor. That's it. Thank you.